Hi, I'm Ramya Devi working as Assistant Professor in SNS College of Engineering. Today I'm going to share a topic on backpropagation and regularization in deep learning. Regularization is a technique used to avoid overfitting in the neural network model, and it is the most common problem in which the training error and testing error is too large. The complexity of the model is higher than that of the actual problem, and the model performs well in the training set but poorly in the testing set. There are four most commonly used techniques to avoid overfitting issue. The first one is L2 and L1 regularization. The second one is dropout, and the third technique is data augmentation, and the fourth technique is early stopping. So L2 and L1 regularization. It is the most common types of regularization. These update the general cost function by adding another term known as the regularization term. So basically, cost function is equal to loss, say maybe through binary cross entropy plus regularization term. Due to the addition of this regularization term, the values of weight matrices decrease because it assumes that a neural network with smaller weight matrices leads to simpler models. Therefore, it will also reduce overfitting to quite an extent. However, this regularization term differs in L1 and L2. In L2, we have cost function is equal to loss plus lambda divided by 2m into the modulus of w. So in this, we penalize the absolute value of the weights. Unlike L2, the weights may be reduced to 0 here. Hence, it is very useful when we are trying to compress our model. Otherwise, we usually prefer L2 over it. Next is the dropout technique. This is one of the most interesting types on regularization techniques. It also produces very good results and is consequently the most frequently used regularization technique in the field of deep learning. To understand dropout, we say our neural network structure is akin and also shown below. At every iteration, it randomly selects some nodes and removes them along with all of their incoming and outgoing connections as shown. So each iteration has a different set of nodes, and this results in a different set of outputs. It can also be thought of as an ensemble technique in machine learning. Ensemble nodes usually perform better than a single model as they capture more randomness. Similarly, dropout also performs better than a normal neural network model. This probability of choosing how many nodes should be dropped is the hyperparameter of the dropout function. Dropout can be applied to both the hidden layers as well as the input layers. Next is the data augmentation technique. The simplest way to reduce overfitting is to increase the size of the training data. In machine learning, we were not able to increase the size of training data as the label data was too costly. But now let's consider we are dealing with images. In this case, there are few ways of increasing the size of the training data through rotating the image, flipping the image, scaling, shifting, and then shift plus scaling and rotate plus scaling. So this technique is known as data augmentation. This usually provides a big leap in improving the accuracy of the model. It can be considered as a mandatory trick in order to improve our predictions. Next is the early stopping. Early stopping is a kind of cross-validation strategy where we keep one part of the training set as a validation set. When we see that the performance on the validation set is getting worse, we immediately stop the training on the model. This is known as the early stopping. So we will stop training at the line, since after that our model will start overfitting on the training data. So basically, overfitting of a data means the training data is overfitted with your model. So the model is complexly developed. Because of that only the training overfitting problem occurs. So to avoid that, we use the 4 techniques we have discussed in this video. Thank you.